Welcome to a video that will provide a rough proof of the principal unit normal vector formula. Let's start off with a quick review. If this purple curve is our space curve, orientation in this direction, the red vector would be our unit tangent vector, and the blue vector would be our unit normal vector. And we know these two vectors are orthogonal to one another, and therefore their dot product would be equal to 0. Now if we perform substitution provided by this formula here, we could say that the unit tangent vector dotted with the derivative of the unit tangent vector divided by its magnitude would also have to be equal to 0. The last thing we should mention is that the magnitude of t prime does not affect whether it's orthogonal to another vector. So if this is true, then t dotted with t prime should also equal 0. So this is really what we want to show. If we can show that t dotted with t prime is equal to 0, this would be enough information to verify that t dotted with n would always be 0. Let's go and see if we can develop that idea. We're going to consider the dot product of one vector with itself. Well, since we're dotting this vector with itself, we could rewrite this as the square of the magnitude of the given vector. And we know that this is always going to be equal to a constant. Now let's go ahead and consider the derivative of this dot product. Well, we just said this dot product would be some constant, so this leads us to the derivative of a constant, which we know must be equal to 0. Now we're going to apply a principle of the derivatives of a vector valued function of this dot product. Now this property should remind you of the product rule for differentiation. We have the first vector valued function dotted with the derivative of the second vector valued function plus the derivative of the first vector valued function dotted with the second vector valued function. Now even though the order of these dot products are different, the results would be the same. So this is equal to 2 times r dotted with r prime. But from above, we know that this derivative has to be equal to 0. So if we divide both sides by 2, we could conclude that r dotted with r prime must equal 0. So now we've just shown that any vector valued function dotted with the derivative of itself will always equal 0, and therefore r and r prime are going to be orthogonal. So it follows that t dotted with t prime of t would also equal 0 and therefore are orthogonal. And since n of t is defined by t prime of t divided by the magnitude, it must be true that t of t dotted with n of t would also be 0, and therefore these two vector valued functions will always be orthogonal to one another, and therefore our formula holds. Okay, that's going to do it for this video.